I would like to introduce our esteemed speaker of this evening. He is a graduate of the esteemed Technion Data Scientist program and has over 10 plus years of experience developing database infrastructure. Please welcome the co-founder and VP of R&D for Timbr.ai, Dan Weitzner.
Hi everyone, thank you very much. Thank you very much for the introduction, Eric. I'm very excited to be here. Let me share my screen and let me know if you can see my presentation. So yeah, we can even see everyone here. Nice. So yes, welcome everybody. I hope everyone is excited as I am. I'm glad to be presenting Timbr.ai to fellow SQL super users like yourself, or so I'd like to assume. We're going to talk today about how to leverage SQL superpowers with the SQL Knowledge Graph. That's what we do. But before that, let me talk a little bit about myself. My name is Dan Weitzner. I'm a VP R&D and co-founder of Timbr.ai. I've been a programmer, developer, coder, however you want to call it, for most of my professional career. And in my professional life, I've also been a printer repairman, a remote TV operator, anything slightly tech related that requires a minimum amount of reading instructions or documentations. I like science, philosophy, and I'm also an enthusiast when it comes to knowledge bases and knowledge representation. And in Timbr.ai, we try to bridge the gap between data and knowledge. And we bring it to the standard of the SQL world. In this presentation, I'm going to show our solution to bridging the gap, and I will talk a little bit more about knowledge representation and all the value that our solution brings to the table. Okay, so the gap between data and knowledge is the gap actually between how machines or computers think and how we as humans think. As we all know, machines that have database are likely to be running a relational database, 80%, right? And probably it will support SQL. So machines view the world in terms of logical relational database operations. However, us humans, we view the world in terms of ontologies, concepts and relationships. Even if we don't know, our mind automatically makes distinctions and observations between abstract and material concepts, and as we conceive them in the real world. As database users, moderators, we have all suffered from this gap. We're often required to take the human way of thinking and translate it in terms of tables and columns to answer a particular query. This can be summarized in a tweet, like I saw last month by Seth Rosen, which is the overall sentiment. I bet a lot of you can relate to. Can you just quickly pull this data for me? So someone asks him, and he says, sure, let me just select star from some ideal, clean and pristine table that you think exists. We all know that the data as it's stored and structured in relational databases is not how we as humans think about data and knowledge. So actually there are many solutions in the market that try to solve the gap, but many adoption barriers in the market arose from those solutions. Some solutions require loading and transforming the database for its initial setup, or maybe an ongoing ETL process to ensure new data is always coming into the knowledge. Some require learning a new language to query the data and model the knowledge graph. This usually comes with a steep learning curve. Many knowledge graphs have limited scalability when they try to scale north from 5 terabytes of data. Most knowledge graphs, to my knowledge, do not connect to business intelligence solutions that are available in the market. So data consumers who are not tech savvy can't really enjoy the power of the knowledge graph from their BI tools. Also, I didn't mention the big data elephant in the room that is growing as time goes by. So what about big data? Well, the more data you have, the more problems you are likely to experience. Whether you have to make sense of thousands of hundreds of tables and views, find and combine different relationships to allow transitivity in your queues. Not all columns will be annotated with an explanation. For example, a column of width can be expressed in one table as an integer representing pixels, and in another table it can be a float representing centimeters. The more logic operations you need to follow and apply in an SQL query, the harder it is to share, scale, and reuse the knowledge across the organization. So we took all these challenges in consideration when we created Timbr.ai. Let's talk a little bit deeper about how relational database and human things. A quick summary. Relational database rely on, one moment, sorry. Yes, this. Thank you, yes. Relational database rely on relational algebra. The human mind thinks in terms of knowledge representation, abstract concepts and relationships and what they represent. Relational databases have a flat view of the world, where any table is a private autonomous entity, whereas in the human worldview, everything is multidimensional, connected, and ambiguous. What about inference rules? Relational databases don't have inference rules out of the box, whereas human beings intuitively reason over ontology and semantics without even knowing they're doing it. So they just do it intuitively. In relational databases, everything is an observation, and every query needs to be explicitly defined, whereas in human thought, a query can be explicitly or implicitly defined, and everything can be an observation or an abstraction. Or another word for abstraction would be a distinction. Okay. So we can the difference between using a relational database with Timbr and using a relational database without Timbr can be summed up with the following. Without Timbr, we are left with the immense power of relational algebra and all the joy and productivity it has brought into our lives throughout the years. With Timbr, we still keep the immense power of relational algebra. We add inference rules to it, and then we enjoy all the capabilities and expressivities that is closer to how humans perceive the world. Let's dive a little bit more deeper into the differences. So, is a relational database really that different with or without Timbr? Everything in Timbr is based on what there is in relational databases. Therefore, in some sense, everything corresponds quite nicely one another and behaves similarly. Ontology in Timbr, in addition of being a catalog, has other settings and configurations that correspond specifically to the ontological aspect of the catalog. For example, how many jumps available as graph traversals would you allow to see in the metadata of a concept? Regarding the schemas, all the schemas in the given catalog will also be presented in Timbr, but in addition, you will get 3 different schemas to view the ontology. Each and every one of these schemas has its own applications, and I will talk a little bit more about this in the future slides. Concept is a table or a view, but it has inference and inheritance properties due to the hierarchical nature of the ontology. This also would be discussed a bit more later on. Sorry about that. A column is a property, but instead of the column being constrained by the table where it was created, a property must be consistent across the whole ontology. A column can also be a relationship. When the column is considered a foreign key to another table, relationships like properties must also be consistent throughout the whole ontology. Why do we need these distinctions? How do these distinctions help us? Well, let's begin one by one. flat world versus multidimensional worldview. Okay. When we look at the metadata in any relational database, we can see the flat world of tables, where we find some relationships between the tables as constraints between foreign keys. But overall, each table is its own private entity, and you can't really see any hierarchy between the tables. You can't really understand. But when we look at it from the ontological perspective, we get a multidimensional view of the world where there is an abstract hierarchy with governing rules between concepts. Every concept, table, and every property, or a column, is accounted and can provide context when you query it. Let's take another closer look. Context in relational databases. Two tables examples. Okay, so we have these two tables. If we look at them, our minds, we can almost immediately understand how each row represents a person. In the customers, we have a person. In the leads, we have a person. But there is no real relationship between those two tables. From the table view, it is the customers table, for example, is absolutely agnostic with its relationship to other tables in the schema, unless it was explicitly defined when creating or altering the table. Because of this autonomous nature of each table, each column also lives in a confined environment of the table, which it was defined. What's more, we can consider ourselves lucky if the column is annotated with a description of its content. Some of these questions might come to mind when thinking about the tables. Does height need to be the same data type across tables? Height, this here, and height here needs to be the same data type? No. Do full name, the column of full name, and the column of lead name represent the same thing? Yes, the name of a person. Is weight represented in the same unit of measurement thing across tables? I don't know. This can be in pounds and this can be in kilograms, so I don't really know. Are they talking about the same thing? The name is the same, but the value, not so sure. It's integers, but I'm not so sure. Okay, that's from the columns perspective. And from the tables perspective, what is the relationship between the tables? If this is a person and this is a person, shouldn't they be related somehow? What is conceptually mutual to both tables? We said that full name and lead name mean more or less the same thing, the person's name. Okay, so this is how we view context in relational databases. Context in Timbr, the same story. So you have those two tables, and now we can create an ontology and we can map the tables from their data sources to the abstract concepts that we create. When we create this hierarchy, we can define that person has an ID, a person name, a height, and a weight. And when we create customer and lead inherits from person, they will automatically get these four properties or columns. When we map the data to a concept, we can say that full name corresponds to person name. And same when we map leads, the data of leads to the concept of leads, we can say that lead names represents the person name. When we go and we say, okay, can I select star from person, we get all the customers and all the leads because they're both persons. If I want to look only in the context of a customer, I can query only the customer. So context matters. If you, for example, get this query, select title, name, location from TDB table 2020, limit 3. Pretty straightforward and easy to understand, right? But can we understand the relationships between title, name, and location just by looking at the query? Let's look at the results. Okay, we got a nice table. Can we understand now the relationships between title, name, and location just by looking at the results? No, not really. I mean, Matthew B. Brady can be the creator of this title. He can be the artist of this title. Maybe he's the rights holder of this title. Also, location can be the location of the title. It can be location of the name, and it can be also location that is not really related to either name or title. So only from looking at the query or the results, we can't really conclude the semantics of a query. So how can you determine the semantics of a query? I'll give you an example from how we perceive things. Can you spot the queen? Suddenly you hear that sentence. What does queen refer to? What is the context? Well, a queen can be a person, right? A queen can be the name of a person, like Queen Latifah, or it can refer to the status of a monarchy that a person has, and can be the Queen of England. A queen can refer to the bee queen or the ant queen in the animal kingdom. A queen can also refer to the band or maybe a song. A queen can also refer to a game. You have queen in chess, you have queen in checkers, in cards. In many different games, you have a role of a queen. So when you hear the sentence, can you spot the queen? Can you really know what queen refers to? Let's try to give a deeper look at this question. Okay, so what types of concepts can represent the idea of a queen? Like we said earlier, queen can be a monarch, a person, a bee, an ant, a band, checkers, chess, and cards. But we have other concepts that we know. A person, a bee, and an ant, they all represent animals. Checkers, chess, and cards, they all represent games. And in the semantic web knowledge graph, everything is a thing. Anything can be a thing. Space can be a thing. Time can be a thing. Love can be a thing. Literally anything can be a thing. So, by following reasonable steps, you get the logical consequences. That's inference. So what is the inference in can you spot the queen? A queen, we said, can be a monarch. A monarch is a person is an animal is a thing. A queen can be a person is an animal is a thing. A queen can be a band, a queen can be a game. But once we have this hierarchy clear, we can see that anything is a thing at the end. So how does a knowledge graph translate to SQL? Well, in the most general case, a thing has something to do with thing. That's the generic approach. Okay, so how we do it in Timbr? How does this really translate? Let's take the logical schema. We have 4 tables. For example, a person has a name and an age and a birthplace. Birthplace is a foreign key to cities. Cities have name, population, located in country. Located in country is another foreign key to the countries table. Countries have name, population, located in continent, and you have the continents table. If I want to see all the persons that live in a certain continent, I will have to do a join, another join, and then I can get all the persons that are in the continent. And that's how we think in the logical schema today in relational databases. However, in the conceptual modeling, in Timbr conceptual modeling, just by looking at these 3 tables, we can see, okay, a city is a place, a country is a place, a continent is a place. A person, his birthplace can be a place. It doesn't really have to be a city. It's really easier and faster to analog, to give an analogy about what is the concept that answers what is a city. A city is a location. A city is a place. What is a country? A country is a place. What is a continent? A continent is a place. Place can have name and population, and then city, country, and continent will inherit those properties from place, and each one of them will have its own direct properties created for it. Okay, so what does this mean? If I look at the metadata of a table called Google Campaign, without Timbr, I will see only the columns that Google Campaign has. When I look it through the reference schema in Timbr, I can suddenly see more relationships that I didn't know. From the regular metadata of Google Campaign, city is just a value. In our in Timbr.ai metadata, you can see that city is actually another concept, and that concept has its own properties. So you can jump from a campaign to the city GDP of that campaign, or to the city population, or to the country GDP, or to the country ethnicity. So that's one way that Timbr does semantic enrichment. Another one is what we explained earlier, is the inheritance. If I create a concept of a campaign and I say, okay, Google campaign is a campaign, and I say Facebook campaign is a campaign, Google campaign and Facebook campaign will inherit the properties of the parent concept. But Google campaign may have its own distinct columns, yeah? And Facebook campaign can have its own distinct columns. Okay, so we have three different semantic dimensions for any concept in Timbr in our knowledge graph. This means that you can look at the same concept from three different ways. If I look at from the earlier example, I look at the campaign, just in the regular Timbr schema, I get only the properties that correspond to the concept. If I look at it from the eTimbr, or the exhaustive schema, suddenly I get all the properties of the children of campaign. So if city and country were in Facebook campaign, and age viewer and view time were in Facebook campaign, and I try to look at the metadata of the campaign, I will get all the other columns, and I can also query them, of course, of the underlying concepts, child concepts. In the denormalized schema, we can do graph traversals. In this schema, you will get any other concept, and denoted by a dot, you get the column to its a property that that concept has. Also, if a concept, I can jump from one concept to another concept and get that column value just by denoting another dot. So here I'm jumping from campaign to city, from city to weather, and from weather I bring the average temperature for that city, for that campaign. So these are the three semantic schemas. How we do it, from where we got this idea. We didn't invent it. We took years of research in ontologies, ontology modeling from the web ontology language, which is OWL. It has a data store, a data model of RDF and triple stores. That's the data model and data store. And you query it with a language called Sparkle. We use tables and views for our data model, and data warehouses and data lakes for our data store. It can also be private silos. And our query language is SQL. Okay, let's do a little query comparison, how we compare against Sparkle. So if I want to ask, okay, who are the CEOs of US companies born outside the US? In a Sparkle query, it will look something like that. It's somewhat similar to SQL, but you can see it's not so readable, not so easy to write and understand. However, in SQL, you can do a simple select name, CEO, CEO.birthplace.country as birthplace. So I'm getting the country of the CEO. From dtimbr, because I'm doing a graph traversal in my query, .company, this is the table that I'm, the concept that I'm querying, where country entity label is the United States of America, and the CEO birthplace country entity label is not the United States of America. Pretty easy to understand. How do we compare with graph databases? So this is an example for a query of fraud detection, where you can see that you can get more or less the same complexity in more or less the same amount of code, which is very good. So the complexity of asking questions in SQL is hugely reduced. Okay, let's sum it up a little bit. So to bridge the gap with Timbr as a semantic virtual knowledge graph, we get the following features. We get a knowledge graph that is based on the semantic web principles. You get a virtual layer that is on top of your existing databases. So you never really mutate or change the data. You just read the data, and the virtual layer will do all the query rewrites it needs to do to answer the query. You don't need to do any ETL if your database is already relational. It just stays as it is. All the operations, all the language is in standard SQL. We just extended SQL to have the semantic capabilities. Since the language is SQL, there is seamless integration with BI tools, so we can easily connect to the BI tools in the market. And it was made for big data with big data in mind, so that data lakes and data warehouse, where you have the big variety of data, making this type of order will help you a lot. Okay, so why knowledge graph in SQL? A little bit again. We can connect to everything. SQL has been long enough in the market and is good enough, has a lot of optimizations depending on which data warehouse or data lake you use. We are just a semantic layer that is on top of it. So if your Power BI is used to talk to directly to BigQuery or to Spark, instead of it, Power BI will talk to us. We will push down the query to Apache Spark, and we will return the results. Same thing for machine learning pipelines. If there are pipelines that need to be semantically enriched, instead of doing all the computations and all the transformations in Python in maybe pandas or NumPy or something like that, you can use just the query itself in SQL, get the power of relational algebra to bring you the results faster, and less data preparation and data transformation is required once you have a good ontology defined. And the organizational knowledge. From my personal experience, there were several companies that I started working for, and there was always a legacy, huge SQL that someone once wrote, which is in charge of a particular crucial part of the system, and everyone is afraid to touch, and it's not easy. And managing that piece of code all these years has been a real challenge for a lot of poor DBAs. So I'm sure that people have had this experience before. By arranging your data in an ontology, the organization, all the logic operations get reduced. You can save the logic in a concept. You can always have reference or change it. And you don't really need to change the data. Okay, so we reached the fun part of the presentation. I'm glad we're here. So allow me to exit the presentation. Let me see if you can still see my screen. So our platform is is based on Apache Superset. It's an open source project donated by Airbnb to Apache Software Foundation. And it's a great tool for data exploration and BI. So we also contribute to that project. I think it's still incubating. But we also took it as our platform and we enhanced it. So we added a lot of features to it. to support the creation of the knowledge graph and the querying of the knowledge graph, of course. But you can query the knowledge graph that you create. You don't need a platform to create the knowledge graph. There's a plain DDL syntax if you want to create concepts and map to them and later on query them. You can query the knowledge graph from anything that has a JDBC or ODBC connector to it. So practically everything big. Okay, so what do we see here? We are now in the Ontology Explorer. In the Ontology Explorer, we see the ontology or the metadata. So we can see a list of all the concepts that I currently have. This is ontology is traffic. It's taken from a data set from Google public data sets. One of them is traffic accidents from 2015 and 2016. So we took a look at the data, created the concepts, mapped the data to the concepts, and I will show you a little bit now how we use our tool. So when I click on one concept, every node denotes a concept. And when I click on a concept, I get the concept summary, a short description of what this concept is about, primary keys, entity label, if there are any, the level of the hierarchy the current concept is in, the total properties. We can see it has 3 direct properties, and the total relationships. You can go to the properties tab and see, okay, so accident contributor have accident number, state number, and the vehicle number. We can see that it has relationships, 2 direct relationships to the accident. The relationship name is accident and the target concept is accident. It also has a vehicle as a relationship name to a vehicle info concept, to this one. Okay, so if I take the accident contributors and I double click it, the graph will filter only on the hierarchy below accident contributors. And now, when I right click in it and I choose show relationships, I can see all the relationship that accident contributors is related to. So like we said, it has 2 relationships, one to vehicle, one named vehicle to vehicle info, and one named accident to the accident concept. Okay, when I look at the child concept, accident car contributors is an accident contributor, I can see that it has 3 inherited properties from the parent, and it has 2 direct properties direct to it. Also the relationships, it has only 2 inherited relationships. Same goes for vision obstruction. Vision obstruction also inherits from the concept accident contributors. It has 2 direct properties and 3 inherited properties. And we have 2 direct properties. We can see the concept summary, the hierarchy level. It has a total of 5 properties, 3 are inherited. It's good to have information about each concept. Okay, let's see what data I have here. So I can fetch sample data, and I can see what data, a sample of 50 rows that returns when I query the concept. So you can see each concept gets an entity type, the type of the concept it's related to, an entity label, the label that, the column that expresses the label for that concept, and an entity ID, which is like a primary key that identifies each row in the concept. When I go to accident contributors and I say, okay, let's fetch the sample data from the accident contributors, I can get accident car contributors and also vision obstruction. But in my 50 results, I could not see it. Okay, let's do some queries then to get a better understanding of how this works. So I go to the SQL lab, the SQL editor, saves queries. And let's look at this query first. Okay. So this is the ontology, the Timbr traffic. I can select any schema. I can see that here we're querying the dtimbr schema. So let's see how the metadata for dtimbr accident contributors looks like. Whoa! Suddenly, all the relationships possible, we saw it has only 2 relationships. But all the different relationships I can query now when I look at the concept of accident contributors using the dtimbr schema. When I look at accident contributors from a different schema, let's say the Timbr schema, I will get only the direct properties of that concept. So accident contributors, only 4. When I look at it from the eTimbr schema, oh, there it is, okay. I can also see a little bit of extra columns because each one of the children concept had 2 direct properties. So I can see those direct properties here too. One has to do with the obscured vision. The other one has to do with the car accident contributor. Okay, when I run this query, I get the different types. So I can see that tires is the most accumulated accident car contributor, and rain, snow, fog, smoke, sand, and dust is a vision obstruction that is also an accident contributor. So the different types of accident contributors, I get them only by querying the parent concept, accident contributors. Okay, let's see another example. Oops. Okay. Okay, accident contributors per state. Sounds nice. Okay, when we query, we can see, okay, we're jumping from one concept to another. That's why we're using the dtimbr schema. We're jumping from accident to the state name. We're jumping from accident contributors to the accident concept, and we get from there the state name. So now we got the state name and the accident contributor. We actually did a join behind the scenes here without ever writing or explicitly saying we did a join. Just like we did a union in this query without ever writing anything about a union. Okay, let's see our last example here. A moment. All properties. Show the properties of all the accident contributors. Okay, so this is very simple. It's just select star from eTimbr accident contributors. And we can see we're going to get extra 4 columns that we got from the child concepts. The driver vision obscured by, contributing circumstances ID, and contributing circumstances. That's very nice. Okay, so what happens if I add another accident contributor to the mix? Let's try that. So I'll go back to my Ontology Explorer, and I'm looking at the accident contributors. Let's create a new concept. I'll give it a name. Let's pick damage. Okay, so a damaged car is an accident contributor. Yes, sounds about right. Car damages that might contribute to an accident. We can see that automatically we get accident number, state number, and vehicle number inherited from the accident's contributor concept. And let's add a new property for this concept. Let's call it damage area. And it will be of type string. Looks good enough for me. I click on the plus, and now it added it to the properties that it's going to create for the concept. I'll choose accident number as the primary key for that concept. And I will choose damaged area as the label, default label for that concept. Okay, so I click save, and surely enough, the concept was saved successfully. And now I can see that I have accident car contributed, damaged car, and vision obstruction. But it has no data mapped to it yet. So let's map some data to it. When I right-click on damaged car, and I say, okay, let's add some mappings to it, and suddenly, in the first step, I need to choose the concept. It's already chosen for me, damaged car. In the second step, I need to choose the data source from which I want to map the data from. So I have the schema of traffic that represents what I have in Google BigQuery public dataset, and I can see all the tables that are not yet mapped and all the tables that are mapped. But I'm looking for a specific one. So I'm looking for damage 2015. Looks good enough. Once I choose my data source table, Timbr will try to match the properties one another. But if it can't, you can add your own. Say damage area is damaged areas, and accident number would be consecutive number. All right, but let's try. I can even add a casting if I want for consecutive number to be of type string. And in the mapping, it would be mapped as a cast. I can also add filters to my mappings if I want to add filters to a certain map. So let's create the map. I can give the mapping a name. Let's call it damaged car 2015 and save. And the mapping was saved successfully. So now when I go to damaged car and I say fetch sample data, I'm supposed to see all the data that I have in my data source, but represented as a concept in my ontology. Okay, so what happens if I go back to the query now? Same query, I select star from eTimbr accident contributors. And if I run this query, it's the casting I did. So let me fix the cast. One moment. I can easily go back to the mappings. Oh, shit. I accidentally reloaded the page. One moment. Okay. Let's filter this again. Let's look at the mapping of the damaged car. Let's fix this mapping. Okay, so no. Let's try not to map it. Let's see what happens. No, I have to map it because, oh yes, it's the primary key, that's right. Okay, so let's put a consecutive number. Oh, there's a data type mismatch, that's why. This might be my error. Okay, let's try to run this again. No. Still. Let's see. Okay. But surely enough, it should have worked. It's just this ontology is not really ready. Okay. So let's say it just worked, and I'll just remove this concept I created. Well, I can't remove a concept because it has mappings to it. So I need to remove the mappings first. Okay. And once the mapping is removed, I can delete the concept. All right. So let's see, everything works as it should. Yes, it does, of course. Okay, let's do a little bit of data exploration then. So the data exploration tool is a tool that graphically you see the data. So if in the Ontology Explorer we saw the ontology as a graph, now we're going to see the data as a graph. So the first thing you need to do is choose the ontology that you want to query. We're going to choose the Timbr traffic ontology. And we're going to fetch accident contributors. Let's bring, let's say, about 100 should do it. 100 accident contributors. Let's see what we get back. Okay, we can see we had 5 duplicates. So we disregarded it and we brought a total of 95 results. Now, each node that you see represents a data point or a row in my table. When I click on it, I can see the properties. It doesn't have much, it has only one, and I can see the relationships. So if I click on the accident number of a certain relationship, it will try to traverse to that relationship. Similarly, I can click on the property and a new type of node will appear, which is like a property node. So tires, the state number is 46, for example. Okay, if I turn the automatic inference on by clicking here, then any relationship that I did not ask for can be automatically inferred. So if I go to tires now and click on state number 4, suddenly other concepts that have state number 4 will be connected to it. And since I didn't request for them, they will show as dashed lines and not a straight line. So I know I requested from tires the state number, and the other tires were just inferred by my request. Okay, but what if I want to see the accidents in all the nodes in the graph? No problem. First of all, I can go and I do find data connection, and now I can traverse either through the relationships or through the properties in the graph. Let's start with the relationships. Okay. So I choose the excuse me. I choose the accident concept. And when I bring the accident concept, I can say, oh, yes, I want all the properties that that concept has. Let's say I want 100 as a limit, top limit for this query. And I ask it to find connections. And once it's finished running, it starts the inference process. And we get a very crazy graph with 2 nodes that we brought earlier. Let's remove this node. It doesn't really say much to me. So I remove the selected node only, not all the connected nodes. And computer stuck. Okay. Try this one more. Remove the node. Nope. I wonder why it's choking. You can see I requested this 3 times. Okay. Well, let's try to refresh the page. Okay, let's do this once more. So, we said we bring 100 different accident contributors, and we try to, when the auto infer is on, we try to traverse to the accident concept with all the properties, at least 100 results. Okay. Nice. So now we see different connections, but nothing is really connected, and the accident have no label. So we can easily change that by, first of all, we can group all the accidents to a node, to a single cluster. Let's run again, and we can also add a property. This time, we're gonna choose the, from all the properties that the accident has, I want to try the land use name. Okay, so let's see how the graph will change now. Okay. So still, I don't like the no label for. Let's change that. I can go to the group setting and say, okay, I want the node label for accident to be maybe the route signing name. Okay, so now we can see a local street municipality, interstate, local street. Okay, sounds nice. So we have urban accidents and we have rural accidents. And let's say I want to focus on rural accidents. I double click on to select all the connected nodes, right click, and I do isolate to isolate this from the rest of the graph. And now I'm left only with this. And I can see, I can do another traversal, let's say from accident contributors, this time to a vehicle. And I'm gonna choose all the information I can bring from a certain vehicle. I'll choose 100 different results. And let's say, let's add a filter to it as well. Let's add where the roadway condition, roadway surface condition name would be equal to dry. Let's try that. And also, I want to say that maybe the registration state name should be, let's see, one of Alabama and South Dakota. Let's try that. Okay. So now you see we have these filters. And try to get those relationships. And now we got all the vehicles that answer the query. They must be in Alabama or South Dakota, and they must have a dry surface condition name. I can easily check that if I go to vehicle info and, for example, choose the state name or the roadway condition. So, registration state. So many different possibilities. Registration state. Let's see. Okay, so it's a number, but if it was a name, I bet this is either Alabama or South Dakota. We can also find the correct property name and add it to the graph. Registration state name. This is, one is Alabama and the other one is probably South Dakota. So as you can see, you can do many different data exploration through graph traversals. In the new version of Timbr, you also have different tabs. You can save exploration and you can load them later on from the database. So you can do stopping points and stuff like that. You can also have different views or change what you want to see or not. Let's look a little bit about the visualizations that we get with the platform. So if I go to the Timbr traffic ontology as well, again, and this time we'll try to visualize the accident concepts. So let's visualize this as a chart. Okay, this looks pretty okay. Then remove the columns. And let's change the visualization type. I don't want to show a table. We can do an SQL query for that. Nightline no rows is very nice visualization. It's based on time, so I don't know if we have a time metric. Let's check the columns. Hour will do good, but it's not temporal. So to make it temporal, we just check it. One moment. I didn't finish reloading yet. Oh, I need to choose the metric. The metric will be a simple count. And now we can choose the hour as temporal and save it. Okay, so now we have the hour is our temporal column. We can run this query just to see what we get. I don't like the annotation of the hour, so I'm going to change the formatting of the hour to be something like this. And now we can see the count of all the accidents per hour. So we know that at 6 p.m. And 5 p.m. and 8 p.m. they have the most, this is the most prevalent time for an accident. Let's try to slice and dice this by state. So if I group by state name, for example, and I run the query again, I can suddenly get a better breakdown by state of the time of accidents. So if I want to focus only on, for example, Arkansas, Kansas, Nevada, South Carolina, Kentucky, New Hampshire, and California, I can see the distribution of those states here in the graph. And if I want to focus on a particular hour, let's say 8 p.m. is a good accident hour, if there's such a thing as a good accident hour. And we can see California has most accidents, followed by South Carolina, Kentucky, Arkansas, and the distribution for specifically this hour. So this is more or less the end of my presentation. We can start the Q&A if you wish.
And there were several questions for Q&A in the chat that were pretty good. I texted them to you. I don't know if you got the text.
Oh, I don't know, but let me see. Should I stop sharing my screen or continue?
Yeah, stop sharing your screen if you're done showing things. Let me try to scroll up because now they went up in the chat. There was a question from Justo Carell. How do you choose which graph search method is optimal? That's the first question I picked up that I thought was very good.
I didn't hear. Can you please repeat that?
Sure. How do you choose which graph search method is optimal?
Graph search method. Okay, yeah. So graph search method has more to do with graph algorithms and graph databases. There are certain algorithms that are better for one thing or another. In our field, we do have some integration with, we're currently in a partnership going on with NVIDIA for CU graph, and we want to add graph algorithms to our system. It's in our roadmap, but we currently don't have any graph algorithms in our platform. Generally, there are different graph algorithms for different things. If you want to see, for example, which which node in your graph has the most centrality is the most crucial component in a connected network, then maybe you should use a between a centrality algorithm. For example, each algorithm has its pros and cons. That's more or less what I can say about it.
Okay, Lawrence Garcia also asked a good question. Can you migrate your existing database to Timbr.ai?
Of course, you don't really need to migrate anything. If you want to use Timbr, once you have a license, all you have to do is create a new ontology, and when you create the new ontology, you specify what is the data source from which you'll have the data to map to your abstract concepts. So you don't really need to migrate any data. The data stays where it is. It's a virtual layer. Let me give you a nice analogy that might help you understand more what we do and how we do it. So if we give an analogy of a database is a room, okay? So a messy room. Everyone has a mess in their data, so they have a messy room. What we provide is like a type of glasses that when you wear on the glasses, everything seems in perfect order. So when you're not wearing the glasses and I ask you, can you please bring me the blue pen from your room? And you enter your room and the blue pen is underneath the blanket, behind the sofa, somewhere like that. You won't know how to get exactly that pen to give it to me. But with our platform, you have like these glasses that when you put them on, you see exactly where the pen is and how you can reach it. So we bring order into a chaotic world, or at least we try to.
Okay, Leon Champani asks, how is this data stored? Do we retain it in a DBMS or is it exported into a graph?
The data store.
I think it's a reference to what you were demonstrating from your computer before.
Yes. So the data store is the same data store. The data is still in relational in a relational database. So if you're using MySQL or you're using Postgres, that's where the data is. What we do is we do like a query rewrite. So we take a simple query and rewrite it to a very complicated query. And we also take into account all the ontological rules and everything. But at the end, we do like a query rewrite and we push it down to the underlying databases. So from one side, you don't lose all the optimizations and all the things that you already have in your database. And on the other hand, you don't really need to move the data around or change it anywhere. You just work on the abstraction layer and you query the abstraction layer we provide.
If anyone has questions, please put them in the chat now because I'm scrolling down and I'm reaching the bottom soon at this rate. Don McGimsey asks, what would happen in the case of a many-to-many relationships like a social graph like Twitter? Would you end up with a Cartesian product?
That's a great question. I love that question. Yes, you can end up in a Cartesian problem, of course, but you don't really have to. It all depends on how you organize your data and how everything works. You can specify how many jumps you want to do from one concept to another, and even if a table is recursive, let's say you have a table of people, and you know that a person is a friend of another person, and the person is the father of another person, and everything happens in the same table. So you have relationships to the same table. Many-to-many relationships are expressed as relationships in our data, and there is no problem getting, if your backend can withstand the computation of the query, there is no problem. in executing any query, any type of query, even if it produces a type of Cartesian product.
Okay, so I lost track of who asked this question because it was a back and forth chat, so forgive me whoever gets the credit. But somebody wanted to know if you can use Timbr in place of your favorite BI tool, and if that's the case, then there's no need for Tableau as a question for visualization.
Oh, yes, you can use Timbr for the BI as a BI tool. I mean, of course, no problem. We welcome it, but we also want to give you the option, if you are already used to a certain BI tool in your organization, then you can continue using your favorite BI tool, but suddenly you'll be enriched with all these semantic capabilities.
Okay, Don McGimpsey wants to know if you've done projects with FinReg or other established regulatory ontologies.
Excuse me, can you repeat that?
Don McGimpsey wants to know, have you done projects with FinReg or other established regulatory ontologies?
No, not yet. Not yet, but I would be glad to hear more about it.
Okay, and the last question, so if anyone has more questions, you got to put them in the chat, please. Can you use GraphQL with Timbr?
Yes, I mean, if I'm not mistaken, GraphQL is like an API endpoint where you can query the database. If so, if it's what I think it is, then yes, of course, there is no problem. You query it exactly the same as you would query any other SQL database.
Anybody have more questions? Now's the time to throw it in the chat. Ah, there we go. That's a good one. Malik Jajal wants to know if Timbr.ai is HIPAA compliant.
That's a good question. I think so, but I don't really know. So don't take my word for it. I can follow up and answer this question later on. The real answer is I'm not sure. I'm not the right person to ask it.
Tom Brown says, is Timbr.ai GDPR?
Should be, because at the end of the day, we're virtual. So if your relational database is GDPR ready, we are GDPR ready as well. If your database is not GDPR ready, we are not GDPR ready. Yes. So that's more or less it. We don't store any data.
Any more questions? Okay, so, oh wait, is more. If your database is HIPAA or GDPR, then Timbr, oh, okay. Someone's just, Tim Cohen's also confirming what you just said. Okay.
Yes.
Are there any other questions? Because, here we go, that's good. Is there any, so Chandrash Ag wants to know if there's any feature to mask the PHI, PII data and transmit data to non-production environments or migrate to other geolocations.
I'm not sure I understood the question. I'm sorry.
Look in the chat because I'm also not understanding it fully. Or Chandrash, can you clarify that a little bit?
Yes, can you please elaborate?
Personally identifiable info, PII. Now I got it. Okay. Is there any feature to mask personally identifiable information both in the data storage and in transmission?
Yes, yes, of course. When you specify the data source, you need to put in the credentials to connect to the data source. So yes, there is masking, and we don't keep the data is encrypted in memory, and it cannot be queried or retrieved. It's just stored and matched against.
Okay. Wait, now I'm going to give it another minute or so for more questions. If anyone wants to put them in. Is there any, Angel Victoria wants to know, is there any role separation between the administrator and regular users?
Yes, of course. There is a role separation that comes out of the box with Superset. That's in the platform itself. You can specify which users are read-only and which users have privileges to create ontologies and to query them. So the general answer is yes.
Okay.
That's a good question.
It is a good question. I like this question. Jitendra Thakur wants to know what Timbr stands for.
Well, that's a big secret. No, I'm just kidding. Timbr is an abbreviation of Tim Berners-Lee, the creator of the World Wide Web, and the HTTP protocol. We wanted to, yes, give him credit for his awesome invention.
That's really nice. I would never have guessed that. That's really cool. Tim Berners-Lee. Okay. Angel Victoria has a follow-up question: is can the admin role, people with admin role, see that confidential data? My guess is the question means, is it encrypted in a way they can't see it?
No, the administrators cannot see the confidential data. Again, once you enter the correct username, password, or you put in a private key maybe to authenticate or anything like that, it gets encrypted, it cannot be retrieved, it can only be matched against. So no, even admins cannot see passwords. They can request a reset. They can ask to reset the password, but they don't. They can't see really.
Don McKimsey wants to know: is the performance a direct relationship to the underlying database?
Yes, Don, you got it. The performance is a direct relationship to the underlying database. We do what we can to optimize the queries, and we have plans for having better performance and more optimization. But overall, it really depends on your backend. So if you're using a data warehouse at Amazon, in Google, in Microsoft, it doesn't really matter. We would really love to keep using their optimizations to their infrastructure. I bet it's very good as well, so you enjoy it. And also, that's from the good part. From the less good part, if you have a sucky backend with not many resources, then you will probably suffer performance-wise due to that.
Andresh Agh wants to know details of licensing, presumably for Timbr.
That's a great question, Chandrash. If you want, we can follow up on it later on, and me or someone from Timbr will provide you with more information. Okay.
I'm trying to pronounce it correctly. Bharat Chaturvedi, he asks, is Timbr have its own data store?
Java, not exactly. We're mostly virtual. We do have some ontologically related data, metadata saved in our solution, but no, we don't store or change any data. We're just doing abstractions over the relational database.
Chandrash Agh wants to know, what are the minimum configuration, my guess is it means minimum hardware, in terms of server, client related to Windows, Unix, Linux, hardware and software minimums?
You need to have a Java runtime environment or Java development kit, version 8 or above. More than that, you don't really need anything. It doesn't matter. We can work on Windows, Unix, Linux, works perfectly everywhere.
Lian Champani wants to know, are there fine-grained controls on the data in Timbr outside of the database?
Fine-grained controls. What do you mean exactly by fine-grained controls?
Leon, can you please specify?
Like data wrangling? Is that the question?
That's all he wrote so far. All right.
Okay.
Oh yeah, he wrote yes, like wrangling.
Well, yes, we have a little bit of that, and we want to enhance it even more. We see that one of the pain points of many users in the field is always making sense and order out of the data, and that always requires some sort of data wrangling. So we will, currently we don't have a lot of features in that area, but in the near future we will have, say in the next few months.
So two people asked basically the same question. Serge Davidoff and Chandrish Agh both want to know if there is a community version to play with. Chandrish one is also adding so they can benchmark it against their existing database, SQL Server, Oracle DB2.
Well, currently there is not yet a community version and not yet an evaluation. If you want to try it, we have different endpoints that we can give you so you can play with it, but it will require a little bit of follow-up after this meetup. I would be glad to help where I can. So, yes.
Eugene Tabachnik wants to know if the data is encrypted and we need to query it to show the result to an authorized person. Is that possible?
Excuse me, I didn't hear.
Eugene Tabachnik wants to know that if data is encrypted and we need to query it to show the result, do we need to query it? No, but we need to query it to show the result to an authorized person. How do we go about that?
What if the data is encrypted, but we need to query it?
I think he's asking, like, what is the limit? If you do encrypt the data, how do you get it back? I think that's really what he's asking.
No, I think there was a misunderstanding. We don't encrypt any data. We don't change any data. The only data that we encrypt and store in memory are the credentials to access the database, the data source, the underlying data source. That's the only thing. So if your data is encrypted and you map it to abstract concepts, that's what you'll get when you will query those abstract concepts. I think there was just a little misunderstanding there in the question.
Eric, I just want to add regarding the evaluation. One of the advantages of Timbr is that it's very easy for us to implement a proof of concept for any customer. We can get some data or raw data from the customer and create for the customer ontology based on some business question that the customer has. And in a matter of a couple of days or 3-4 days, we can come back with a system that the user can query and can play with it. So it's a very big advantage because there's a lot of flexibility and no risk really involved in doing a trial.
Yes,
Thanks.
yes, I totally agree.
Okay, so we haven't gotten any more questions, but Dan and Tzvi are here afterwards, are going to hang around to answer questions. At that point, I don't know if I'm going to unmute everyone's microphone. We can try that, see how well that works. If it doesn't, then you can all switch to like one-to-one chat with each other. But they will be here for one-on-one questions. I think now it's a good time to do the raffle for the Kindle Fire HD tablet. Again, this is not released yet. It's coming out only next week, so you'll get it. It'll take you a week and a half to get it in the mail. The way we're going to do this is I am going to pop open the participant list, and we are going to utilize the wonders of latency. So I'm going to put on screen sharing, and hopefully you can see the participant list. And then what I'm going to do is scroll through the list, And Dan will tell me to stop at some random time, and because of latency, he can't actually tell what I'm stopping on until I do it. So let me just get the screen sharing going. Let's see. And hopefully the screen sharing will show you the participants. It is not. Let's see. Hold on a minute. New share. Screen. All right, this may not work as planned. You guys can't see the participant window. It won't let you. Aha. Okay. So that plan didn't work as okay. Hang on. Only one. Well, we got a question while I figure this out. Oh, I have to cancel his share to share it. Okay. No, he's not sharing anymore. I'm sorry, I'm answering the chat. Jitender was trying to troubleshoot it. No, I can share, no problem, but it's not showing the participant window because that's part of Zoom, unfortunately. It's a weird, okay, so my plan for this didn't go as planned. I guess this is going to be on the honor system. Thank you, Chris Simpson, to suggest that. Will trust me. All right, so I am going to start scrolling, and I'm doing it now. I'm sorry you can't see it. Dan, just tell me when to stop, and whoever is under my mouse pointer, that's who's going to win it.
All right. When do I start?
I'm scrolling. You just got to tell me to stop somewhere.
Okay. 1, 2, 3, stop.
Julian Vigil. Oh, wait, I forgot they can't answer back. Julian Vigil, if you're hearing me, type something in the chat. Gotta answer back. Yes, okay, congratulations, Julian Vigil. You have won the all-new Kindle Fire HD tablet that will be released next week. We will contact you using the information you put into the Zoom registration to coordinate getting it shipped to you.
Congratulations.
Okay, I am going to take half my age. Edward, that's a funny way of doing it. But unfortunately, we were actually going to do exactly what Edward said to raffle it off, to do it based on the number of participants and do a random number generator. But as we discovered at the last minute, you can't actually export out the participants until after the event ends. It's a limitation of Zoom. So Edward, though, is a good suggestion. Okay, so we are going to do a chat session now with Dan and Tzvi. I'm going to experiment with unmuting everybody, and I hope it doesn't backfire. If it does, I'm putting everyone back on mute, and you could ask in the chat to be unmuted one at a time. Let's see how well this works. This may not work well. Let's see. Participants. Oh, you know what? Here we go. I can mute everyone and allow them to unmute themselves. Okay, so that's what I just did. So anybody who has a question, just unmute yourself. It should work now, and ask the question. Yeah. Julian, you don't have to do anything. We're going to reach out to you at the end of the session using your contact info you put in your registration.
I have one more question. May I ask?
Yes.
Okay. I would ask to build an ontology model for probably simple case, at the same time not very simple. There are 3 entities. One entity, computer part. The other entity, home entertainment device, like radio, TV, whatever. The third entity, monitor. And can you build ontology? Monitor is type of computer part. At the same time, monitor is a type of home entertainment device. Could you build ontology model, please?
Dan, you're muted.
Sorry, when I muted everyone, I muted Dan too. Hold on. Here we go.
Okay. Eugene, as you probably know, ontology engineers is a very expert field. So you really need to know your stuff to build ontologies correctly, so it will be logically efficient for a long period of time. When you actually build an ontology from our perspective, you need to choose carefully what you want to be a concept, what can be outside of the ontology, You can create a concept that inherits from multiple parents. So you can do that as well if you want. It all depends on the data that you have and how you want to query or use that data. So as to answer your question generally, I think you won't like the answer, but there is no real one true way to do it. People see the world in different ways, think in different ways. Writing a good ontology is like writing a good book. Every word needs to correspond to a sentence, every sentence to a paragraph, every paragraph to a chapter, and every chapter to the overall arc of the book. And the same thing in an ontology. In an ontology, every property, every concept, every relationship, everything needs to be cohesive with the overall ontology, whether it's a small ontology, a part of an ontology, or maybe it's an upper ontology. There are different types of ontologies. It really depends on what is the use case that you're trying to achieve here.
Thank you.
So everybody now has the power to unmute themselves if you have a question. Even if your video is not working, your audio should. Like even if you have your webcam off, I'm saying. So if anyone has a question, now is the time.
Okay, question. Can you define a domain of values that corresponds to your concept? Sort of as a check of what values will be matched into that concept when you connect a source?
Oh, yes, of course. If you want, are you talking like, do you want to make a distinction or like a filter on your data before you map it? Was that the question? Before you map it to a certain concept?
Well, I'm actually trying to answer the question that was the prior question. You basically have devices, but some of these devices will relate only to concept monitors, so you basically want to capture what is the domain of allowed values for a specific concept. So yeah, it's sort of a filtering criteria, if you will.
Yes, you're trying to do like a distinction, right?
You can say that.
Yes, that's part of the capabilities that Knowledge Graph allows. Of course, you can do that in different ways. That's the thing. You can think of device as a property. You can think of device as a concept. You can think of device as maybe a relationship as well. Again, the way that you will model the ontology depends on how do you want to use your data. What type of knowledge are you trying to bring to the table from the underlying data that you have?
But the question is, when I'm defining a concept in Timbr,
yes,
can I add to it the list of values in the domain for a specific field, probably a critical field?
Yes, you can do that. You can do that in different ways. You can either in the mapping process, you can filter those values, and then you can ensure that always those values will be, let's say, for a specific property. And whenever you query that concept, you don't need to think about the logic behind it. You just query the concept and you get the results that you expect.
But you do not store data, right?
No, I do not store data. So, but maybe it will help if I will show you.
So I will have to define this domain on my side, in my source, and then just, work with that.
No. You can keep your source as it is, but when you're matching the source to the concept, you're trying to match one another. That's where you can do a type of filter. It's like you're querying the database with a filter, and the results you load it into a concept. I hope this answers the question. I'm not sure. If you want, we can follow up on this. I will give you a better explanation.
Okay, thank you.
I add something to this question, some answer. It's domain not necessarily will really separate them, because I can use the same TV set as TV just to watch TV shows, and at the same time use it at some other time as computer monitor. It's not necessarily domain. It could be exactly the same physical device, therefore domain will not separate.
Yeah, but you will have the same monitor show up in the domain for the concept device and in the domain for the concept of monitor or something that shows.
I will have it in domain of monitors. That's it. Monitor with sound. Well, let's assume some monitors allow also sound, some don't. Monitor with sound, if it has this feature, it can be used the same, exactly the same, could be in domain of monitors with sound and be used as both TV, regular TV set and computer monitor.
I mean, projector can be a monitor.
Oh, yeah. I'm not going into these details. I mean just two parents of the same entity. I wanted to just have this example to ask about this model.
Yes, so you will just map this, multiple concepts to the same data source. What do you need to do? You need to filter out certain values from this data source for the monitor concept.
What kind of values to filter out?
It all depends what you're trying to achieve. You're both right in the sense that you can do the things that you're saying. You can inherit from two different parents, and then you're actually the intersection between them in some sense. Or you can, when you map the data to a certain concept, you can apply a filter to it, and then you can ensure that when you query that concept, you always that filter will always apply. You can also create a concept that has no data mapped to it, that it's simply a type of logic concept that, let's say it is just a join between different tables or a filtration on a different concept. You can do those things as well. There are other things that I didn't show in the presentation, like you can have relationship from a concept, from one concept to another concept, but you can also have relationship from one concept to the physical data source. So sometimes we have tables that are like two columns, right? Where one is a key and the other one is a value. And so we don't really need to create a concept, or we can always map directly to a concept but sometimes we can use it just as a relationship. So we can say that, let's say a certain key is mapped, and you can always get the values that correspond to it. So it's a relationship to a physical table. It's not a relationship to a concept.
Want to remind everybody, you all have the power to unmute yourselves if you have a question. Okay, I'm going to take that as nobody else has a question. I want to thank you all for coming and give a great big thank you to Dan Weitzner for this great presentation.
Thank you everyone for coming and listening.
Thank you all for being here. I know you can't clap, but I'm going to clap for you, because we won't hear you. But thank you all for coming, and hopefully I'll see you all soon in person.
Thank you very much. Have a great day, everyone. Thank you for coming.
Oh, wait, hold on. Serge just showed you can clap. Thank you, Serge. Okay, reactions. The button on the bottom, reactions, goes to clap. Thank you for pointing that out. Thank you, Brittany, Dan, Tom. All right, see you all at the next event. Thank you all.
Okay, thank you.
Bye-bye.
Bye-bye.